Hello everyone and welcome to our 10.2 lesson on finding arc measures. The first thing we're going to define is a central angle. A central angle is exactly what it sounds like. It's going to be an angle that comes out of our center or our central point. So it's an angle whose vertex is the center of the circle. So in our example right here, the vertex is A, an angle DAC, and that is a central angle. So 70 degrees is the measure of that central angle because this is the circle centered at point C. So angle DAC would be considered a central angle. I could also call that same angle, angle CAD. That is a central angle because its vertex is the center. Central angles are always going to be measured in degrees. These are always going to be in degrees. This is going to be a certain portion of 360. And then what is an arc? Well, an arc is going to be the part of the circle consisting of 2 points called the endpoints and all the points on the circle in between them. So let's look at that central angle, angle CAD that we just talked about, C to A to D. An arc gets cut off, a piece of this circle, and we call that arc DC, starting at D, going to C, and it's all the points in between them. So all of these points get made up in between them. And so that is an arc, and today we're going to be talking about arcs. And those are just going to be pieces of the circle. So what is arc measure? Well, arcs are always measured in degrees as well. A measure in degrees that corresponds to the central angle. So whatever the central angle is, the arc is going to match that. So this shows an X degree. This also shows X degree for this bigger, for this arc here. Okay, so in my picture, in my example, if the green angle is 70, if that is the central angle, the measure of that arc would also be 70 degrees. That is 70 out of 360 is the full amount, and so that would be a 70-degree arc and a 70-degree central angle. Okay, so then we have three kinds of arcs. We have minor arcs, major arcs, and semicircles. So let's start with semicircle. Many of y'all knew when you came into class today that a semicircle is exactly half of a circle. It's a type of arc of a circle whose points lie on the diameter. So whenever you're looking for a semicircle, it's best to look for a diameter first. So let's just start. Let's remember, what is a diameter? A diameter goes exactly halfway across the circle through the center. So here's my center point. It's got both endpoints on the circle, and that is going to be my diameter. Okay, so if that is a diameter, it is going to create two semicircles. We have a semicircle at the very top of this circle from this diameter in pink. We also have a semicircle below that. So both of those are 180 degrees. So anytime you are looking for a semicircle, find a diameter in the circle first. And once you find that diameter, it's going to create two semicircles. Its measure is 180. Okay? Measure is 180 degrees in a semicircle. So what is a minor arc? It's an arc of a circle whose points are on or in the interior of a central angle, but it's going to be smaller than a semicircle, meaning that it's going to be measuring less than 180 degrees. So less than 180 is a minor arc. And then what is a major arc? A major arc is going to be an arc of a circle whose points are on or the exterior of a central angle, and it's going to be larger than a semicircle, meaning it's going to be more than 180 degrees. More than 180 degrees. Okay. So we have minor arcs, major arcs, and we have semicircles, and all of those are still measured in degrees as well. Okay, so we're going to be talking about all of this vocabulary and continuing to practice this. So the next set of directions say identify each of the following using the diagram. Identify the center. What is the dead center middle of the circle? Point K. So the center of the circle is K. It's got that dot right there in the middle. Why does that matter? Because whenever we find a central angle is going to be an angle coming out of the center. So like this angle, JKL, is a central angle. So I'm going to name that JKL. But what I want you to notice is that K is still going to be the vertex of that angle. So not only is it the center, it should also be that middle letter whenever you name a central angle. So JKL. There are several different radii in this picture. K to J, K to I, and K to L, all the same length. So K to I, you could do K to J, K to L. There are also some that aren't even drawn in. There's one from K to H if you wanted to add that one. What is the diameter pictured? We've been practicing this. The diameter that is pictured currently is J to I. And what is a chord in this picture? I could go J to I because the diameter is a type of chord. It has a starting point and an ending point that are on the circle. I could also go J to L. J to L is another chord, which doesn't go through the center. So whenever you name, and I meant to add this to it, whenever you name a minor arc, you're going to get to use 2 letters. And you put an arc over it. Whenever you name a major arc, you have to use 3 letters. And we're going to put an arc over it. Semicircle, we typically use 3 letters to name a specific semicircle. And you're always going to put an arc over it as well. So all of these are arcs. We always use the arc terminology and arc, what's the word I'm looking for? The symbols for drawing that out. Make sure that you have the correct notation. That's the word I was looking for. Okay, so how do we name a minor arc? We need 2 letters. So when you name minor arcs, major arcs, and semicircles, what you're going to do is you're always going to use the letters that are on the circle. And so the letters that are on the circle are J, H, I, and L. So let's just name a few minor arcs. J to H is minor because it measures less than 180. H to I is minor. It measures less than 180. I to L is minor. And we could keep going. There's a lot more. But you only use 2 letters. Okay, so when you name that minor arc J to H, let's go ahead and outline that. There is also an arc on the other side. If that is minor, that is major. I'm going to do it in yellow. But this is why you need 2 letters. If I just said, hey, go from J to H, you would take the shortest distance, which is around the curve of J to H, the red one. But if I wanted to go the other direction, I would need to indicate that by saying, hey, I want you to start at J, and I want you to go through L, and then stop at H. So that would create this, starting at J, going through L, or going through I. So another way to name that same one would be J-I-H, J to I to H. So it gives you a starting point and a stopping point, but it shows you to go the other way. So for major arcs, we need at least 3 letters. We need 3 letters to show the direction you're going in. Starting at J, going through L, stopping at H. Okay. So what is a semicircle in this picture? Well, we are looking for a diameter first whenever we're looking for a semicircle. So where is the diameter in my picture? I chose the diameter of JI. That is going to create 2 semicircles, the semicircle that is on top of this diameter and the semicircle that is on the bottom of this diameter. So what is the semicircle that is on top of this diameter? I'm going to use 3. JHI. JHI is going to be a semicircle. And then JLI is going to be my yellow semicircle. J to L to I. Okay. I could also reverse this. I could go I to H to J and I to L to J. That names the same semicircle. All right, we are going to solve for the indicated values. Now I want you to notice that the first 2 questions ask for the measure of arcs. The next 2 questions ask for the measure of the angles. And remember that these are going to give us the same amount. The central angle should always match the measure of the arc that is intercepted. So when we ask, what is the measure of P to R? The measure of that arc P to R, it is going to match the central angle at PUR. So what is the central angle at PUR? There is a 90-degree box right there, the little marking. That's going to indicate that is 90 degrees. That is a fourth of the circle, a fourth of 360. That is a minor arc, so it should in fact measure less than 180. I know that whenever they put TSQ, it's not going to be a minor arc. It's at least going to be either a semicircle or a major arc. So it's starting at T, which is here, going through S, and then stopping at Q. So we know that this is major. It measures more than 180. And when I'm looking at this, I do notice that I have a 19-degree angle, which is part of it, and then I don't know the rest. So how do I figure out what the rest is? Well, what I do notice is that I have a diameter on here. S to Q is a diameter, which means that this piece right here must be 180 degrees. That divides the circle in half. So what is 180 plus 19? That is going to give me 199 degrees for the measure of TSQ. TSQ. Okay. How do I find angle SUR? So the measure of the angle starting at S, going into the central angle at U, and then going out to R. So SUR is this angle. Well, that angle should match this arc, this red arc. And so I have a, I know it's going to be less than 180, less than 180 degrees. And so what we're going to do to find that angle SUR is we are going to take this diameter and have another diameter. I'm going to put it in purple. I'm going to take this diameter, T to R, and acknowledge that this would make 180 degrees. There's a semicircle. And so what is 180 minus that 19-degree angle? That is going to give me 161 degrees for the measure of angle SUR. Okay? SUR. So that would give me 161, which means that arc SR if I wanted to know what that is as well. So if this is 161, that means that the arc from S to R is also 161 degrees, which is a minor arc. All right, last but not least, we want to find the measure of P to U to Q. So I'm going to highlight that. P to U to Q. Okay. This is part of that 90-degree box, but it's not the whole thing. So how do I figure out how much has not been used? Well, we've got 19 degrees on this side, and this is going to create vertical angles. So there's 19 degrees on this side. And so we're going to take 90 and we're going to subtract 19. Whenever I do that, that is going to give me 90 minus 19 is going to give me 71 degrees. So we've got a 71 degree angle right there. All right, so let's keep going. What we just did is we found the missing pieces. And so whenever we go to the next problem, it is going to be very similar. So my advice is if you're watching this video, go ahead and pause it and then check it with the answers in a second. Okay, so I've got some central angles marked. I've got this one is 40. I've got this central angle is 25. So of course I know that those arcs are also 40 and 25. And we want to find what is the measure of arc LN. So this is just like the arc addition postulate is just like the segment addition postulate, which says that if you add the pieces together, the smaller pieces, it adds up to the whole. So that is going to be 40 plus 25. So let's write that down. 40 plus 25 is going to be the measure of LN. So that is going to give me a 65-degree arc for L to N. How do I find J to L? Where is J to L? So let me go a different color. J to L starts at J, goes to L. It's a minor arc, so I need to go this way. Shortest distance around that circle, J to L, the smaller distance. And so how do I find that? Well, I do notice that that is not quite a semicircle, but I do have a semicircle happening right here with this diameter. So what I'm going to do is I'm going to say, okay, well, if that whole thing is 180, if this full amount in blue is 180 degrees from here to here, well, then I'm not using, in the pink one, I'm not using that, this matches this central angle. I'm not using that 40, and so we would do 180 degrees minus the 40, and that's going to give me 140 for that arc. So J to L would be 140 degrees, that entire pink amount. Okay, how do I find angle LJN? I'm sorry, arc LJN is what it says, L to J to N. So what I'm going to do is I'm going to start at L. I'm going to go to J, and I'm going to go all the way around to N. So I'm going to erase some of this picture just to kind of clean this up a little bit. We want that arc. We know it's going to be major. It's not the angle. It's going to be an arc starting at L, going through point J, and then stopping right at N. Okay? So there's a few different ways you can do this. I think one of the easiest ways that a lot of people figured out in class is that this is a full 360, and so the red part is going to be the yellow amount less than that. So I had a student in class that said, well, you just take the 360 and you subtract off what you didn't use, which is the 40 and the 25. Minus 40 minus 25. Okay. You could all find all the small pieces and add them all up together, which is what I had another student do in my other class. But what I love about math is that this does not contradict itself. Okay, so that is going to be a 295-degree arc. So that is major. It is more than 180, and that is how you would find it. So how do we find K to P to L? KPL starts here, goes to the center point, and comes out at L, so that is a central angle. How do I find this central angle? Well, it should match this arc right here. And I believe we've already found what that was. If I wanted to create a diameter, that would be this piece. And so how do I find what is here? I can subtract off, or what is here, I can subtract off the two central angles on this side from 180 degrees. So I can take the full amount, which is 180, and I can subtract off minus 40 minus 25. So we're going to do 180, semicircle, minus 40 minus 25, which gives me 115 degrees. Okay. That would be both the measure of the arc. That would also be the measure of the central angle. Okay. All right. On this next problem, we're actually going to go to the last one first. I want to solve for x, so immediately I look at which arcs have an x in them. J to K contains an x, and then K to L, that arc, contains an x. And what do we know about the relationship between those two arcs? Well, I know that J to L is a diameter, which makes a 180-degree central angle here. It also makes a 180-degree arc. So what do I know about the yellow plus the pink? Those should have a sum of 180 degrees. So 5x plus 23 plus 17x minus 41 is going to have a grand total sum of 180. Those should add up to 180. So when I put my variables, my like terms together, I get 22x minus 18 equals 180. I'm going to add 18 to both sides, and I get 22x equals 198, I believe. And then I'm going to divide by 22. So 198 divided by 22, I believe, gives me 9, and it does. So x is 9. Okay. How do we find, now that we know that x is 9, how do we find the measure of arc JM? J to M. Well, that is going to match the central angle. We know that. And so we already know that those are vertical angles. This star angle and this star angle are vertical angles. And so we get to plug it into that pink expression. That pink arc should be the same as the green arc. So we're going to do 17 times 7. I'm sorry, 17 times 9 is what I'm plugging in. So 17 times 9 minus 41. And that is going to give me 112 degrees for this pink arc, which means that this green arc is going to be 112 degrees as well. How do I find an angle? So now I'm looking for an angle JNK, J to N to K. That's this central angle. Well, that central angle is going to be congruent to that yellow arc. So I'm just going to plug in a 9 here. So 5 times 9 plus 23 is going to give me a total of 68 degrees. Another way one of my other classes figured that out is they said, okay, well, I've got a semicircle right here as well. So 180 minus 112 also gives me 68 degrees. All right, we did some multiple choice test taking practice on this, and so oftentimes you'll see questions like this on standardized tests because they want to take real world data and say, how would this present on a circle? So they have made a pie chart here. They've made a graphic of music sales, the different like genres of music, so rock, rap, R&B, country, pop, classical, jazz, and other. So how do we find the measure of arc BC? So starting at B, going to C. So that is going to be our rap category. So what we want to know is in this rap category, what is the measure or how much of the 360 does rap take up? And so when we turn 13% into a decimal, that is going to be 13 out of 100. When you do 13 out of 100, you're going to get 0.13. So we're trying to figure out, well, what is 13% of 360 degrees? So you're just going to type in, you can either do 13 divided by 100 and then multiply that by 360, or you can just type in 0.13 times 360. So what is that degree? What is the central angle and the arc going to measure? It is going to measure 46.8 degrees. So this is a 46.8 degree angle. Okay. How do you find FMC? So starting at F, going to M, central angle, and then coming out at C. What categories does that entail? That includes your pop, your country, and your R&B. So what is 9 plus 10 plus 11? That is going to give me 30% of this circle is going to be pop, country, and R&B. So I'm going to do, that would be 0.30 times 360. So what is 30% of 360? 0.3 times 360 is going to give me 108 degrees, would be what this arc is. It's also going to be the measure of angle FMC. That is a 108 degree angle. All three of those categories take up 108 degrees of the circle. Okay. Now we're switching gears and we're going back to arcs. What is the measure of AHB? A, starting at A, going to H, and then all the way around to B. So this is a major arc. So one way to do this is to add up 26, 3, 3, 9, 10, 11, and 46.8. Or you could acknowledge that we have used 75% of the circle. How do I know that? Because I am excluding the rock, which is 25%. And so that is going to give me 75% of the circle, so 0.75. And that is going to give me, oh, y'all, I added the wrong numbers together. There we go. The 46, so 0.75 times 360. So I'm working with, the numbers you would add together is the 13, not the 46.8. So I shouldn't have added those together. If you added together, I'm going to highlight them. If you added together 26, 3, 3, 9, 10, 11, and 13%, that would add up to 75. That is the percentage of the circle I'm working with. You could also just do 100% minus 25%, which is what I did, which is 75%. So what is 75% of 360? This is something y'all are actually used to. That is going to be 270 degrees, which is, y'all are used to that number because we rotated things 270 degrees in the coordinate plane. So it wasn't quite a full circle, it was 3/4 of a circle. Okay? And then last but not least, what is the measure of EMD, central angle, E to M to D? So what category is that? Country. So if we want to figure out what percent of the circle is country, I'm going to do 10%, which is 0.10, times 360, and let's see what this angle is. That is going to be 36 degrees. So not only is this in the country category, not only is this going to be 36 degrees for the central angle, the measure of arc ED would also be 36 degrees. Okay. So your homework is on the back. I did want to make a comment for the people that are not here to fix this for me. I had already printed this out. For number 9, change these values or change these letters from S, whatever it was, S something, S to U to R. Those letters are obviously not in the circle, so change that to CPD, and then change this CPB, and then change the other one to CPD. So number 9, it should be the measure of angle CPB, and the bottom one should be the measure of angle CPD, just to make it match that circle. And that is our 10.2 homework, and we will check that tomorrow.